Thank you very much. It's really great to be here, and it's really great to see so many people show up. Thank you so much to our fantastic hosts. I think we can all agree that we've got a really neat venue to meet up in and really nice food to go with, so thanks again. So when I talk about explanations, this is the sort of thing that makes me think. This is something that actually came up on my Facebook feed one day. My response to this is, by the way, I know my voice goes quiet. If at any point it goes too low, just tell me, up it a bit. So the question I have then is, Facebook, what is it you think you know about me that this becomes relevant? What information have you collected that this makes it relevant? The funny fact about this that you don't know is that I have been to Egypt, and I did get a tummy bug, but this was way before the days of Facebook. And to my knowledge, I have never discussed this on Facebook. So unless talks like this are being analyzed, put into text, and fed back to Facebook, there's no way they would know. Right, so a lot of us are interacting with recommender systems from day to day, or developing recommender systems that act effectively as black boxes. I'm sure you've heard this term before. And there's some sort of little magic man. For me, I prefer to think of this as Yoda. You might have your own idol that you aspire to have working within your systems. But at some point, this fella is trying to explain things. There are a few things I want to illustrate by this, and I should add that this is not a recommendation that was given to me. I have stolen it from Twitter, but I think it's a wonderful example. Think for yourself whether or not you think this actually qualifies as a good explanation. So basically, you're being recommended Harry Potter because of some short stories from Dostoevsky. Those of us that work with recommender systems can sort of see where this might have happened, right? There's a user-user correlation, and this is how this was computed. I would claim that in some ways it's a really good explanation, and in some ways it's really bad. So it's bad in the sense that this isn't actually related to the item. It doesn't explain much about the item to me, but it does actually have some fidelity to the algorithm. It does actually give us an intuition of what might be happening under the hood. So this is a bit closer maybe to an aim of transparency and less related to an aim of effectiveness. You might have a different feel about this, but I do want to get you guys just thinking a little bit about what the properties of a good explanation might be. Let's go back a step. Why should we explain at all? So I started my thesis on explanations about 10, 11 years ago. I am old enough to have done that at this stage, doing a PhD on the topic. Why care? Any motivation that we have in life, we might classify as something we love, and we're trying to move towards it, and something we hate and we're trying to move away from it. We might translate that as the carrot and stick analogy with horses. The stick might be the new GDPR laws. We are now asked by our laws and by regulation by, 2018, to produce algorithms that are fully explainable to the user. Our boss says we need to do it, therefore we will. Our heart is not in it, but we definitely don't want to be fined. Okay. The carrot, on the other hand, is maybe something I want to talk to you about today. I should argue I am an academic, so maybe I have some privileges not having to worry about my job on the line there. However, I do have an interest here. Maybe we can do things better. Maybe we can improve the transparency of recommender systems. And when I say good, I mean something quite specific. I actually mean helping people make good decisions. What do I mean about good decisions, though? Well, when I did my PhD, I looked at a delta in opinion change. And what I studied there was what impression people had for an item before they consumed it, and the impression that they had of the item after. I looked at that difference, and I tried to minimize it. The idea being that if your opinion changes a lot after you've consumed the item, you probably were not given the right information. So if you thought you were going to love an item, you bought it, you brought it home, and you hated it, the explanation wasn't that great. Works the other way. You didn't buy the item, your friend bought it, and you're totally envious. Pretty crappy explanation too. But again, this is work that I did about 10 years ago. my ideas of what constitutes a good explanation has changed since. And you'll see in the work that I'm trying to push forward now, I'm looking at other things. I'm looking at recommendation moving more and more towards search. So can we use explanations to support people in their exploration of the domain? Can we help them understand the decision space and the options that are available to them? And in particular, I'm interested in the concept of filter bubbles. So can we indeed use explanations to help people look outside their comfort zone and not only consume items that they have liked in the past? I should perhaps give you an anecdotal definition of the filter bubble. Elie Parissier gives a really lovely TED talk, if you manage to see it, if you haven't seen it before, whereby people on his Facebook feed were always agreeing with him politically. And this was because he was interacting more with people that agreed with him politically. And he was never exposed to the other side of the political spectrum. So when I say filter bubble, I mean not being exposed to ideas, points of view, items that maybe challenge us a little bit. So back to my PhD, what did I actually do? Well, I looked at generation of textual explanations. What sort of textual explanations can we generate that support people in making good decisions? I started out with a very simple baseline for comparison. Let's see if this movie is in the top 250 in IMDb. Not very clever, but easy enough to check. And then I compared that with personalized explanations that considered which features were important to a person and actually how those features related for that particular item. And I compared it with still a rather factual, richer explanation, but that didn't consider that maybe this person thought that actors was an important feature to look at. And I evaluated these in a few different ways of looking at explanations. So when I was starting my PhD, people didn't have really a consensus of why we might want to explain. And that's where this whole conversation started from. Do we want to have a greater fidelity to the algorithm? Do we want to increase the transparency? Or do we actually want to increase decision support or effectiveness? As I was defining it here, this was the decision delta. Do we rather want to look at persuasive explanations? And I was having this conversation with someone earlier. A lot of people that I spoke to at the time said, well, a recommendation is, by definition, a persuasive element because you're trying to get someone to buy it. And my argument to that was, are you sure? Because maybe sometimes we should be trying to persuade users not to buy items and through that gain long-term loyalty. Do we not go back to shops where they say, you know what, you can get that cheaper around the corner, but if you want this other item, I'll sell you this? Right, those are the shops that we return to. So persuasion might not always be the metric that you're trying to evaluate on. What I in fact found, and it was quite counterintuitive to what I thought, and most people that I speak to about this research say, is the personalized explanations. They did do better, but on one dimension, user satisfaction. Users liked the personalized explanations, but what do you think it did for decision support? It was worse. Decision delta was bigger. And this was because people formed stronger opinions. Because it addressed things that they cared about, they were more likely to use the full scope of the scale. Okay, well, enough about old work. Oh. This renders differently on the screen than on my laptop. There are two cases where we might want to apply explanations. One is novelty, and the other is when we have trade-offs in the explanation, in the recommendations that we get. Right? So the work that I'm working towards now looks at what can we do in terms of the interfaces to help users deal with items that are surprising to them and help them deal with trade-offs that are taken for the explanations. Now, you might argue that, well, we already have multi-attribute recommendation algorithms that consider the multiple attributes, that consider the weighting between these relative attributes. But are we actually able to explain this to users? Are users really able to understand the trade-off that was made for them? If I am given a place to visit on my holiday, do I understand that it's recommended to me not because of my interest profile, but because of sheer proximity, and that actually the next point of interest is going to fit my profile better? Right? So this is something that explanations can help us understand, that there's a trade-off being made on our behalf on certain instances. So a little bit about novelty and explanations. One might argue that diversity is the strength of recommender systems in some way. So we've seen probably the long tail in various formats. I happen to like a dinosaur, but that's me. The head of the dinosaur are the Harry Potters of the world. Lots and lots of Harry Potters sold. You don't really need a recommender system to predict them. If you give it to your average person, it will probably sell. What recommender systems do well are to deal with the items that fewer people buy, but substantial enough to have a stock of. Because all of us like to think that we're special little snowflakes. Right? So this is a strength that we should be leveraging, and to some degree we are. But when we have items that we don't know that much about, we tend to be reticent about recommending them in systems. So these may be items with high variance, with low confidence, or items that are simply coming in as part of cold start. We don't really know whether or not they're going to be good recommendations with as much confidence as we do other items. And then we might not recommend them at all. And I think this is where explanations come to the fore. I don't think that we should be explaining every single item, but we should be looking at when explanations are beneficial. And the other risk is, well, we're not looking at just financial benefits for companies. Great, I think this is important. But we also have a certain societal responsibility when we're looking at tailoring content, making sure that people don't get stuck too much in fixed ideas. So I have a personal bias here. I left the UK post-Brexit, and I did see that half of the population was effectively not speaking to the other half, not in person, not online. We were simply not exposed to differing points of view. And I have to say this is terrifying. I mean, this is not a decision that is resulting in war, but there are pretty big political divides within the country at the moment. And if we keep on supporting this with both our human biases to confirm our own opinions and the algorithms that are increasingly polarizing our views, we might be looking at a very polarized and dire world indeed. So hopefully, explanations have a role to play in this, helping us take that little leap and say, I'm not fully sure, but maybe you should look at this. Okay, so what have I done in this space? I've got 15 minutes and many projects. You'll get a few, and we have a chance to talk later. This is some work that I did in California. My colleagues at the Four Eyes Lab, John O'Donovan, was the main collaborator on this, but Jay Kang was the guy that actually programmed the system, and I think fair due for kudos. So the idea that we're trying to leverage here is effectively weak links. So if you look at your social network, the people that you follow on Twitter are pretty indicative of the sort of interests that you have. But what about the people they follow? Your friends of friends. These are the weak links that might still be relevant to you, but are slightly outside your comfort zone. So this is one way of diversifying the content, by picking out who you follow and then picking out from their friends who you follow. So this was an interface to help users explore the space. So these were my first degree follows, and you could actually select up to 3 of these. We didn't have a fire hose, so we couldn't leave the number of interactions to be indefinite, and this would result in a number of hashtags that those people were actually using, and similarly the second degree follows, and they're hashtagged, which would later result in a customized feed. So you could see much better how your interactions were actually affecting the content that you were getting. So this is published in SOSINFO last year, and we also have a workshop paper on this work a year before that. Some other work that I've done on this, this isn't published yet. This is currently under review, so enjoy. We were trying to think about what to do about the part of the item space that people don't even know exists. So there's stuff that we sort of know exists, but we know we haven't explored it yet. So this movie is out in the cinema, but I don't know if it's good or not, that sort of thing. But there's stuff that we just don't even know to start thinking about, the unknown unknowns. So we thought long and hard, is there something that we can do in terms of interfaces, in terms of visualizations that could somehow improve? So, well, what sort of transparency have people got for the coverage of their profiles? So if I look at my profile in Movie Lens, I can actually get something like this. This is a bit of a fake profile because I've seen a lot more movies than that. Thank you very much. But you can see that there's a certain distribution here across genres. There's some genres I see more and some genres that I see less. Okay, so that gives me a bit of a feel. But there are some things that it doesn't let me know. It doesn't let me know about the movies that belong to several genres. It doesn't let me know how I compare to the rest of the population, and it doesn't let me know how I compare to the existing movies. Because in fact, if you look at the number of ratings in the Movie Lens dataset, they're not equally distributed across genres. I mean, things like musical and horror, tiny, tiny little genres in comparison. So, okay, what can we do? Well, being a scientist, I thought, well, we need to have a baseline that's more or less comparable. So here, the dark bars are representing exactly the same thing. How many movies have you seen in those genres? But the lighter gray represents something else. These are my blind spots. These are genres as they are distributed for other users. For all other users, how much have they seen them? So for this given profile, I would conclude that I watch less kids' movies than other people. I don't have kids. Fair dues, right? And then we compared it with another interface. Somewhat more complex. Right? And this is a bar chart, chord diagram. So comparing a bar chart with a chord diagram. So just to give you a quick overview, same thing we did with the experimental participants, because it's not fair to assume people can read it straight off. We do have clusters that belong to the individual dramas, right? So this is a bit of movies that are just dramas. But then we also have movies that are drama and romance, drama and thriller. Right? So the darker bars are representing my movie patterns, but in relation to several genres at once. But then it also represents the genres that I haven't watched in a very similar way. So that information is very similar. But the bridges are different. So there's a bridge here between drama and war. So despite the fact that drama is a very big genre, my profile, I'm not really watching, and I watch some war movies. For some reason, I'm not watching movies that belong to both. Can I use that bridge as a leverage to watch more war movies? So one of the questions that we had to users, the first one is, do you even understand this? Right? These were psychology students, so fairly bright, but okay, maybe not great at reading graphs. No biases here. I studied psych, not as my first degree, I'll have you know, but yes. But the second question we asked them, can you actually answer certain questions about this? And one set of questions just had to do, what is the most popular genre? What is the genre you watch the most? And following that, what is the next genre that you watch? After that, the bar chart did great. Right? It's nice and easy, accessible, they could do that. But when we're looking at combinations, of course, they can't answer that with the bar chart. And they were able to deduce that from the chord diagram just fine. But the really interesting thing was, okay, what are you going potentially to watch next? Assume that this is your profile. What is the sort of movie that you would be looking at next? And using these bridges, they were much more likely to watch a grayed out, a blind spot bridge than they were otherwise. So please. Oh, we're out of time. Cool. So this is an encouraging result that there's something that we can do to help people to explore parts of their search space that they don't know about. So we're starting to understand what works in terms of interfaces, in terms of interactions to help people discover new content and the sort of explanations and interactions that we need. But can we do something from the algorithmic side? And this is where more and more my work is going now. So we're looking at different diversification strategies. One of the things I've been looking at is how do people perceive diversity in a playlist such as the one that we receive on Spotify. And there's a project that I've started there that looks particularly at sequences of recommendations. So when we're looking at, say, a tourist itinerary, do we need to consider the fact that somebody doesn't want to see several museums in the same day? Things like this. I think we'll maybe share the slides afterwards rather than me going through it bit by bit. I've also been looking at, can we look particularly at news? And I'm really excited to have the other speakers here. This was not on purpose from my side, but really, really excited about it. I've been working with developers of a tool called Rebutter. It's an online argumentation tool where people are linking websites for things like autism is caused by vaccines. So you might have a website claiming something like this, and you're trying to find a counter-argument against it. So somebody can link to something saying, well, that argument that was once published in The Lancet has been withdrawn. Somebody can link to that page and say, yes, but this other study that you're referring to is also funded by a pharmaceutical. Keeping people skeptical and trying to introduce this as a basis of a corpus of pro and con arguments for different things. I think I'll move through that. So I'm working with students together to help them, support them in critical thinking, but my sort of side angle is, can we then use this as a corpus, a collection of arguments to create diverse ways of looking at a single piece of information or a single statement. So if you look at my work as a whole, we have on the one hand explanation interfaces, and on the other hand explanation-aware algorithms, things like considering how we're applying sequences and what the composition of sequences are, or how diverse items are within a set. But ultimately, what I want to know is, how is this affecting humans and how they make decisions? And this ultimately is done by experimentation, very much in the way that you would see psychologists running studies in their labs. So indeed, what happens is we have a feedback loop. So I run my experiments, it affects how I suggest the algorithms be implemented, and it changes the way I design the interfaces, and on it goes. So what do I want you to take home from today? Explanations are great, but they're not always good. And one of the reasons they're not always good is that you sort of need to know how you're defining your goodness. They also don't always do what you expect. So if you remember my PhD thesis, I was saying the explanations were very satisfying and users liked them. They didn't necessarily make better decisions. To do that, I would strongly recommend evaluating with people. I appreciate that this is a very costly thing, and getting people into a company or into a lab isn't always the most cost-effective thing. But the problem is that what we think as engineers is an intuitive solution is not always what actually happens with real people. We forget sometimes that we're not rational beings. We need to look at explanation-aware interfaces, but we also need to look at the underlying algorithms and the content that we're recommending to people when we're designing our systems. And my sincere hope that I can see you guys in, say, a year's time and say we've slightly mitigated the filter bubbles as a consequence. Finally, and this isn't a topic I've had time to really delve into, but I see explanations as a two-way street. We get something from the system in terms of how it works, but we also should be able to tell the system, no, I don't agree with you, and this is why. And some of the work that I've done is in the field of formal argumentation, computational argumentation, actually structure these arguments that we might have with systems, and indeed this is where I'm going with the rebutter system, to have the data that we can to start having a bit more of a two-way conversation. Right. So if you want to follow up in any way, I have a website, email, Twitter. I also exist in other places in the web, but this is probably where I'm likely to respond. And I think that's it from me for now.
Thank you.
Questions?
Is there a type of algorithm that works better than others for feedback?
I think that's a very fair and pertinent question. So the problem sits with fidelity. If you're looking at deep learning algorithms, I think no one has crunched that one yet and probably won't for a long time. The thing that has struck me, though, that even if you say, okay, if we have the perfect content-based algorithm and we have all the information that we ideally could have for a user, do we know what explanation is best? And that question hadn't been answered for a long time.
Any other questions? Of course, one aspect I'm curious about is how many people care about explanations? Is there any? You can imagine that differs across domains and user groups and whatever. But how often do people even look at them? Consider them?
I don't have numbers. I do know of some studies where explanations were not used as much as the users or the system designers expected. My intuition is people use explanations when things go wrong or when things are unexpected. So it's a little bit like the big red button on a factory floor. People are very rarely pressing it, but they're very comforted by the fact that it's available and that they can.
Right.
It also depends on the degree of investment. I think that when we're talking about reading the wrong book or seeing the wrong movie, that's a loss of time, but nobody's going to die as a consequence. We're currently talking about the possibility of working with people in humanitarian aid who are trying to interpret algorithms that decide where you build a bathroom or something like that and where you put running water. And I think there, having an explanation and being accountable for the decision that you made is much more important. Thanks.
How do you separate, say, pop-up recommendation systems, say for like Amazon, and pop-up advertising? Say advertising that comes up with recommendations for you because you have a cookie plan or browsing history.
How do I feel about the fact that it's unsolicited rather than requested and explanations possibly being intrusive? Yeah. So I also discussed this in the context of application domain. I generally feel like it's something that users should request. It should be something of added value. But if you think on one extreme, you might have someone who's in an autonomous vehicle and he's trying to sort out the driving, and all of a sudden this explanation is coming out about where to get a petrol station. That interrupts the driving and might be a traffic hazard. Right, so it depends where the cognitive load of that user is currently sitting. The question about the consumer products and intrusiveness is a slightly different one because there is an intent behind to get someone to buy something that isn't really for the user's benefit. It's just,
Isn't that with all recommendation systems? I mean, isn't that a pervasive feeling? I mean, I have that.
you could also view recommender system as an artificial advice giver, and this is why I'm also pushing this idea of a good recommender system is one that will also tell you not to buy something or reasons why it hasn't considered specific options. This is not a view that all people working with recommender systems share, I appreciate, but this is where I come to the table. Yeah.
Okay, final question.
Very interesting, thanks. One question at the beginning, you said that when you do explain where a recommendation comes from, you notice that people had a different anticipation of the product or the movie or whatever. Would you find that the delta was changing more to the extremes, I guess? Would you say that that is because the initial expectation would move to an extreme?
Yeah, so the initial expectation was deviating from the mid,
Yeah.
and then it was moving closer to, so yes, we're starting from the poles and moving towards the middle.
Yeah.
I also looked at these very non-informative explanations just to see what happens, and I gave people the option of opting out. I said, you know what, if you don't, because, okay, so if you put it in the middle of the scale, does that mean that you don't know, or does it mean that you're, I really don't care?
Yeah.
And when you give them really crappy explanations, they will opt out.
Yeah.
So that's a bit comforting to know that there is a subtle difference there.
Cool. So, thank you again.
Thanks, everyone.